Greetings. So this is Graham Warren working with you on scenario analysis using the AnyLogic simulation model for the Antico Cafe Greco case. So we've elaborated some basics about this model, which it is a discrete event model with two resource pools, one for Venus Arduinos, one for Jura machines. Pay attention to your case owner as to what is permissible, whether you can only have Arduinos or Juras, or maybe a mix, but that's up to the case owner. We've already investigated the base case, in which we just picked out one barista who receives orders at the rate of 18 per hour, processes them at the rate of 35 per hour. But services are actually normally distributed with a mean of 103 seconds and a standard deviation of 60 seconds if they're untrained or have basic training. And we found that we had an estimate, I think, about 54% utilization of that barista. That barista is identical to the other two baristas, so no need to analyze all three. We just analyze one, and we understand what the performance of the system looks like. Waiting time in system was around 3 minutes. So let's see if we can change this up a little bit and get ourselves some analysis that so we can figure out what advanced barista training would look like. All that changes is it takes our standard deviation down. Now, of course, there are the other benefits layered on that with the latte art, sophistication, leadership, and so forth. But from a performance standpoint, that's the main improvement. They have their act together. They're less variable. There's a range of beverage types that they're making, but they're making them in a more consistent manner, essentially, because the standard deviation is coming down. And we can just run that. Now, one of the things to notice when you run a simulation analysis is that you will typically have to do multiple runs, and I will do a few runs here. Also, just talk about the animation. You can see that when work accumulates here a little bit, let's see, we've got just the early beginnings here of customers coming in. I'll speed this up. Now, you can see some work accumulating here. Those are folks that are waiting. And you can, perhaps see these, what look like bats or something just flying through here. I'm on a Windows box. If you're on a Mac or a different type of machine, the representation of this animation may be a little different, but they kind of look like people, but they're sort of flying through here. So you can see here they're waiting, and then this is the actual service process. And when they hit this sort of green circle, they're done. And they would be leaving the system. So that's sort of a very basic way of visualizing, what's going on here. You can slow this down so that you can actually observe them sort of going through here. There it is. Okay, coffee's in process for that person. They're done, and there's the next one. And the variation in those processing times is because, the times are normally distributed. So some are going to be very quick and others are going to be long. So think espresso versus maybe, some sort of elaborate latte. Okay, so I'm going to run this one fast to completion. Now this fast forward block takes us out to a specific time, which we can control by clicking on the little wheel here. I'm actually simulating 10,000 minutes. And in the 10,000 minutes, I had around 3,000 customers. That should be good enough to get a real good sense of the time and system distribution, the utilization, which is estimated at 51% for the Arduinos. Of course, there are no Juras in here. So just one Arduino that's being estimated here. And you can see a little improvement in the service time, waiting time in system from about 3 minutes down to 271. But the problem here is that this is just like showing up at a cafe one day and observing it. We really want to, come in multiple days to make sure that, we're getting a representative look at what's going to go on. So you can stop this and just rerun it. And so now I've got and it went all the way out to 10,000 minutes again, instantaneously, because it's a really small model. Instead of getting 271, I got 278 now, and I got 52% rather than the 51% the previous time. So I would run it a few times, stop it again, and run it again, and 285 now. And then you average out the results. You could also build a confidence interval to express the variance to your audience. Because it really is, a variable work environment. Some days the average weight's going to be 270, other days a little higher than that. So to get a representative average, you probably need to do 3 to 5 simulations at least. All right, so that is the base case with an advanced training innovation. Let's go back to the base case and see what happens if we switch out the Arduinos for Juras. So I'm going to just take it back to the base case, and I'm just going to take away that barista that we're looking at and give them a Jura. And you can see that the service distribution, the standard deviation of the service time distribution is now 5, because that's what the Juras bring. They automatic versus semi-automatic Venus Arduinos. And I'm going to run this one. And again, you'd probably want to do 3 to 5 runs. So let's just see how this goes. So what's going to happen now is there's going to be no utilization on the Venus Arduinos. That's going to stay at 0. So there it is. But the Jura is working, right? There's one Jura. All that's happened is we took the Venus Arduino away from the barista, gave him a Jura. Same average processing time, but smaller standard deviation. Now I'm going to speed this up, run it all the way to completion by doing that. And I'm going to get 10,000 minutes. Again, served about 3,000 customers. And my average time in systems 262. But we are getting some, high-end completions, very long completions. Don't know if we had, how many are out at 15, but it's clear there's some bumps here at 7-8 minutes. So it's just something to note. And we'll run this one again. Okay, 269 this time. And again, 263 this time. Estimate is about 50%. Utilization hasn't changed much compared to having a Venus Arduino in there. Okay, so that's the substitution of the Venus Arduino for a Jura. Let's go back to the Venus Arduino, the base case. So take away the Jura, hand back the Venus Arduino. Hand back the Venus Arduino. And what I want to do now is I want to pool the orders. So to get pool orders, all I'm going to do is I'm going to just say, okay, so there are 54 per hour coming at the 3 baristas in total. They're each seeing 18 per hour in the base case. Excuse me. But if I lump those together, they're seeing a combined order stream of 54 per hour. Turns out that if I superimpose Poisson arrivals, that the resulting superimposed or aggregated process is also a Poisson process with the increased arrival rate. Now, here I messed that up. I should have not done that. I want to put 3 in here. And I do have 60 seconds as the standard deviation. So these are the basic baristas, basically trained baristas, serving a combined order pool. And we'll run this to see how this goes. Again, you'd want to do multiple runs and just average out and maybe build a confidence interval. So I'll run it to completion. So there are the 3. You can see how many are available, 0, 1, 2, or 3 different times. Still doing about, below 50s here, percentage-wise. My waiting time in system estimate is 2 minutes. Let's try that again. So now 54%, 2 minutes average, really consistent results. So, replication isn't as crucial here as it may be in other simulations. You can see the max time is around 5 minutes. Something to think about. Of course, there are folks who are getting almost instantaneous service down the bottom here, average 2, but realize that, because there's a distribution on this, that pain is present for some. All right, now want to finish. I want to look at maybe some combined scenario. So what about we try these pooled orders with jurors. Put in 3. What about just 2? How's that? Try this. So I basically pink slipped one barista here, gave the other 2 baristas jurors, pull their orders. That's where we are. And we'll run this. Okay, so let's just accelerate to completion. So I'm estimating. So they're all jurors. There's 2 jurors here. See, 0 of 2 available right now. 77% utilized. About 3 minutes turnaround. You can see all the details here. 54 arrival rate. Just to confirm, that's the nice thing about having the output here. You can see the arrival rate is per hour, mean service time, and the standard deviations are in seconds. Of course, the number of Venus Arduinos has to be an integer value. So yeah, you could use this tool to give examine a blend, and just for the sake of for interest, I will plug one of these in and just show you that it's possible. I don't know if this is going to be admissible. Talk to the case owner. But you would want to do multiple runs in each of these scenarios, whatever you're looking at. Accelerate to completion here. So here I have one barista who is 70%, 67% utilized. The jurors only 45% utilized. Mostly around 2 minutes. You can see a very high peak here, but there are some folks experiencing wait times at 4 or 5 minutes. Run this one more time for you. Same kind of result. Got a lot of capacity. The Venus Arduinos are working harder than the jurors. And one last one, just to get a sense. So yeah, it looks like to be about 2 minutes. So this is some basic scenario analysis for you. Again, the numbers need to be weighed in the context of the coffee shop, and I look forward to seeing what you do with this. Enjoy.